Hi guys, in this video we are going to take a look at an application of the method of Lagrange multipliers to solving a problem of minimizing the cost of a box with a given volume. So the volume function, that's going to be your constraint, right? Because we know that the volume is 200. So the volume of a box with height z and length and width x and y will just be a product of the x, y, z. So, and then if I move the 200 to the other side, that's going to be 0. So this right here is the g of x, y, z. Okay, so I enter here. All right, and then the function to be minimized is the cost of the box. So let's think about what is the cost of the box. So if I send you to Home Depot and I tell you to buy material for the box, what I will look at is, okay, well, each square foot costs 8 cents if it's the top or bottom. But how many square feet do I need? Well, if the x is the length and y is the width, then I will need x multiplied by y square feet, right? So each square foot costs 8 cents, so or a square centimeter, whatever, doesn't matter. Okay, so this is just going to be 8xy. That would be the total cost for the bottom. For the top, it's going to be the same thing because the price is the same. So that's going to be also 8xy. So you can see that what the top and the bottom both have the same exact area, x times y. Okay, so now let's deal with the sides. So let's say we are talking about now we also have to find the cost of the right and the left. Okay, so the area is yz and the cost is 9 cents. So that would be 9yz. And that's for the right side, to make the right side of the box. Another 9yz is for the left. And finally, the front and the back, they also cost 9. But the area of the front is xz, so that would be xz and another 9xz for the back. All right, so that totals to 16xy plus 18yz plus 18xz. Okay, so next we need to deal with the gradients because the method of Lagrange multipliers says that you are supposed to find the gradients and then they should be proportionate to each other at the points, what we call critical points, where the maximum or the minimum, in this case, it'll be the minimum, will occur. All right, so for gradient of f, because it has 3 terms, you have to be careful and take the derivative of each term separately. So 16xy with respect to x will be 16y. 18yz will be 0 because it doesn't have an x. And then 18xz will become 18z, right? Okay, because 18 and z are constant multiples. Now, similarly with derivative with respect to y, from the first term is 16x, from the second term would be 18z, and nothing from the last term. Finally, for the z derivative, we will get nothing from the first term, 18y plus 18x. Okay, so that is the gradient of f. Now let's deal with the gradient of g. That one's much simpler because there's only one term. 200 obviously will disappear when you take the derivative. So that'll just be yz for x, xz for y, and xy for z. All right, so once you get the gradients, what you're supposed to do is you're supposed to figure out a number lambda such as gradient of f is equal to some multiple, which is called Lagrange multiplier, by times gradient of g. So we don't really need these lambdas. We do not need to figure out what they are. Well, what it is or whatever. So this is just going to be, we just divide x by x, and then I'm also going to divide y component by the y component, and the z component by 18y plus 18x divided by xy. What you're going to do is first look at the first proportion. And the first and the second, I mean. And then you're going to cross multiply. And a lot of things are going to cancel, but some things will not. So we'll see what cancels. So if I multiply this part by this, so what you're doing is you're multiplying this by that. And that'll become xz times 16y plus 18z. And then that's equal to, let me pick another color. So it'll be this part multiplied by this right here. So that's going to be yz times 16x plus 18z. Okay, so opening this up, distributing, we'll get 16xyz plus 18xz squared. On the other side, you're also going to get 16xyz plus 18yz squared. Okay, so subtracting 16xyz, we can see that that just cancels on both sides. And then we wind up with 18xz squared equal to, oops, 18xz squared equal to 18yz squared, and which means that we can also divide both sides by z squared, because remember they're not zeros. Also divide by 18, and from here we figured out that y is equal to x. Okay, so we now have one connection between x and y. Very good. But now we also have to get the connection between z and x. How do we do that? Well, for that, we actually will need the following. So the first and the third term here. So we're going to cross multiply. So we're going to multiply 16y plus 18z. We're going to multiply that by xy. And then we're going to multiply 18y plus 18x, multiply that by yz. Okay, so let's see if we can simplify that. So this will be 16xy squared plus 18xyz. On the other side, we're going to get 18y squared z plus 18xyz. So what do we see happening? We see that 18xyz and 18xyz cancels out on both sides. So that gives me 16xy squared equal 18y squared z. Now, what can we cancel here? So we can cancel y squared. That goes away. But pretty much that's it. So we're going to have to divide both sides by 18 so that we can express z in terms of x. So that'll give me z equals 16 over 18. It is really nothing much we can simplify here other than just say that that's 8/9 of multiplied by x. Okay, so now we have connection between z and x. And if you're wondering what else we're supposed to do, and that what else is always go back to the constraint. So constraint has to be used at the end, okay? So if you didn't use it, that means you messed up. Now, the constraint says that x, y, z is equal to 100. So let's plug it in. So we already know that y is x, right? Because we showed that on the right there, right over here. And then z equals 8/9 x. So we plug that in there, and that should be 200. Okay, so let's multiply both sides by 9/8, so that by the reciprocal, so we can cancel, right? We will cancel 9 with 9, and we'll cancel 8 with 8. Okay, so on this side we'll get x cubed equal, well, whatever is 200 divided by 8 and multiplied by 9. I'm not so sure what that is, so I will use my calculator. And it tells me that that's 220. So I'm going to enter an exact answer. So I'll just go with the cube root of 225 here. This is another cube root of 225. And then this is 8/9 of cube root of 225. Okay, so once we got that, we have to get the cost. So what does that mean? What that means is what we got for xyz has to be substituted into the f of xyz function, and we are going to need to just figure out what that is. Okay, so we're just going to need to plug in. So let me have the calculator here on the right side, and I'll just define my function f of xyz to be equal to 16xy plus 18yz plus 18xz. Okay, what I want is substitute cube root of 225 for x, and then a comma, and then another cube root of 225 for y, and finally the 8/9 cube root of 225. Okay, so that gave me the cost in cents. Now, because you can't really round down, you cannot have 1775.67. It's like millicents or something like that. So you have to round up. What that means is that you're not really rounding. You never go down. You always go up. So you can just basically ignore this part and just go up by 1. Instead of 1775, you're going to get 1776. So that's your answer. So even if this number 6 was like a 2 or something, you would still enter 1776, which really means it's $17.76. That's how much it's going to cost. Oops, hold on. 1776. Okay, I just messed it up, but let me submit it.